Welcome to all. In this video, I'm going to discuss about rules of inference related to quantifier. There are two types of quantifiers, universal quantifiers and existential quantifiers. The rules related to inferring the conclusion are universal specification, universal generalization, existential specification, existential generalization. Universal specification is nothing but from general statement to specified statement. That is for all x, p of x into p of c. Similarly, second one is p of c implies for all x, p of x. Existential specification is nothing but there exists x p of x implies p of c. An existential generalization is from the specified statement to generalized statement, that is there exists x p of x. Let us see one example. Here show that there exists x m of x follows logically from the premises for all x h of x then m of x and there exists x h of x. So the given premises are for all x h of x then m of x and there exists x h of x. And from that one we have to derive the conclusion as there exists x m of x. So here we have to introduce the premise one by one. So let us introduce the first premise for all x h of x then m of x. So whenever we are introducing the premise, we have to mention it is rule P. Similarly, second one is in the second step, we have converted the specified statement into a h of c to m of c. Similarly, there exists x h of x will become h of c. And if I am combining second and fourth step, we'll get m of c. The conclusion part is in terms of the quantifier there exists x. So we can convert m of c into there exists x m of x, which is our required result. Next one is show that p of a comma negation p of a comma b follows logically from the premises negation w of a comma b and for all x p of x comma y then w of x comma y. So here is also we are introducing the premise one by one. In step 1 we have introduced for all x for all y p of x comma y then w of x comma y. Whenever you are introducing the premise we are denoting the reason as rule P. Here is also we are converting the generalized statement into specified one but for each and every variable separately. First we are introducing the premise for x. So whenever we are converting the generalized statement into a specified one, x will convert into a. So for all y, p of a comma y, then w of a comma y. And we applied the rule universal specification only for the variable x. Similarly, again we are applying the rule universal specification for the variable y, which will become p of a comma b, then w of a comma b. Again introduce the second premise, negation w of a comma b. And if I am combining the step 3 and 5, 3 and 4, you'll get the step negation p of a comma b. Next one is show that the premises one student in this class knows how to write program in Java and everyone knows how to write program in Java can get a high paying job. Imply the conclusion that someone in the class can get a high paying job. First thing we have to convert the proposition into a symbolized form and before that we have to denote the variables. Here a of x is denoting x is in the class and b of x is denoting x knows how to write program in Java and h of x denoting x can get a paying job. So for the first statement, that is one student in this class knows how to write program in Java, which will become there exists x one student a of x and b of x. And then the second statement is everyone knows how to write program in Java can get a high paying job. So which will become for all x b of x then h of x. And the conclusion is someone in this class knows how to write program in Java can get a high paying job. So which will become there exists x a of x and h of x. So we had to introduce the premise one by one. So first step, we are introducing there exists x, a of x and b of x. Whenever you are introducing the premise which is rule P, and you have to convert the generalized statement into a particular statement which will become a of c and b of c. And the name of that rule is existential specification. And a and b we can replace in terms of p and q separately, that is a of c separately and b of c separately. And for all x, b of x, then h of x will convert into b of c, then h of c. And if I am combining 4 and 6 step, which will become h of c using the law p comma p then q is equivalent to q. Next step, if I am combining a and h using the law p comma q implies p and q will get a of c and h of c. And the conclusion is in terms of quantifier. So we are converting the specified statement into a particular case generalized statement, which is there exists x, a of x and h of x, which is the required conclusion. Thank you.